let's talk about a huge tension at the very heart of AI right now. We're getting these incredibly powerful, smart AI agents, but they come with a hidden sticker shock that's getting harder and harder to ignore. And that really brings us to the big question, doesn't it? We've all seen those mind-blowing demos of AI agents solving complex problems. But the moment you try to use them for a real-world application, the costs can be, well, staggering. It really makes you wonder, are these amazing tools becoming victims of their own success? Are they getting too expensive to actually use? And this is the fundamental conflict right here. On one side, you've got these incredible new powers. I mean, AI agents can reason, plan, and work through multi-step problems in ways that felt like pure science fiction just a couple of years back. But then you look at the other side, and a single one of those tasks might make hundreds of separate API calls, racking up a bill that makes you think twice about deploying it at scale. So how did we even get here? Well, it's a pattern we've seen time and time again in the tech world. First, researchers push the limits, going all out for maximum performance and breakthrough capabilities. It's only later that the focus shifts to making it efficient, affordable, and practical. It looks like the world of AI agents has officially hit that exact inflection point. And look, the researchers behind this work, they don't mince words. They call this cost a fundamental bottleneck. And that's the key word, right? It's not just an inconvenience, it's something that actively limits who can build with this tech and how far it can scale. This isn't just a technical problem, it's an accessibility problem for all of us. So to figure out where all that money is going, the researchers did what any good engineer would do. They decided it was time to pop the hood, take the whole thing apart, and see exactly where the waste and inefficiencies were hiding. They put 5 key components under the microscope. You know, the whole shebang. They looked at the core brain, the backbone LLM, the planning module that decides what to do next, the tools it uses, its memory system, and even the common strategies people use to try and squeeze out a little more accuracy. Any one of these could be the cost culprit. Now, to measure all this, they needed one single, super clear metric. And what they came up with is brilliant. It's called cost of pass. The idea is simple. How much money, on average, does it cost you to get one single correct answer? You just take the cost for one try and divide it by how often the agent actually succeeds. Lower is better. This number is going to be our North Star for the rest of this explainer. Okay, this is where things get really, really interesting. Because when the researchers started testing those components, what they found kind of flips a lot of what we thought we knew on its head. It turns out, when it comes to building an efficient AI agent, bigger and more complex is definitely not always better. First up, they went after memory. Now, the common wisdom has always been that for an agent to be smart, it needs a sophisticated memory, right? One that can summarize past events and learn from them. But is that really true? Do you need all that complexity? The results were pretty shocking. Look at this. The most complex and expensive system, summarized memory, was actually the worst performer. It had the highest cost of pass and the lowest accuracy. In fact, having no special memory at all was better. But the clear winner, by a long shot, was simple memory, which is basically just a raw log of what happened. It was both the cheapest and the most accurate. So the takeaway here is crystal clear. You don't need some fancy, over-engineered memory system that costs a fortune to run. For these kinds of tasks, a simple, raw history isn't just cheaper, it actually works better. Okay, next on the myth-busting list is a really common strategy called best of n. The logic seems solid, just have the AI try the same problem, say 4 times, and then you pick the best-looking answer. People do this all the time to try and boost accuracy, but what's the actual cost? Well, the data shows a classic case of diminishing returns. I mean, look at this. You quadruple the work and the cost, but your accuracy goes up by, what, 0.5%? It's a tiny, tiny gain. Meanwhile, your cost of pass jumps way up. You're paying a whole lot more for basically nothing. So the verdict on this strategy, yeah, it's just not worth it. While it might sound like a good idea in theory, in the real world, best of n is an incredibly inefficient way to chase a tiny marginal improvement. All right, let's move on to another core function, planning. An agent needs to be able to think a few steps ahead. And the assumption is that giving an agent more steps to think or plan should lead to better results. It just seems logical, right? The more time an agent has to think, the better the answer should be. Or should it? Well, this chart tells a fascinating story. It's all about a balancing act. Going from a max of 4 steps to 8 definitely helps. But then, when you let it go all the way to 12 steps, performance barely budges, but your cost of pass goes through the roof. The researchers have a great term for this: overthinking. The agent is just burning cash without getting any smarter. So it's all about finding that sweet spot. You have to give the agent enough room to breathe and plan, but too much freedom just leads to that costly overthinking. For peak efficiency, moderate planning complexity is the name of the game. So after systematically finding all these different sources of waste, the researchers didn't just stop and write a report. They took everything they learned and said, okay, let's build something better. They set out to create a new blueprint for an agent, built from the ground up for pure efficiency. And here it is. This is their recipe for an efficient agent. It's a perfect summary of everything we just saw. First, use a strong but balanced model, not necessarily the absolute biggest one. Second, set a moderate number of planning steps. They found 8 was the sweet spot. Third, let it search multiple places for info but keep the web browsing simple. Fourth, just say no to expensive tricks like best of n. And finally, use that super simple raw memory system that we saw work so well. So the big question is, did it work? Oh yeah, it worked. They tested their new efficient agent against other popular frameworks. One called Small Agents had a staggering cost of pass of almost $6. A leading agent, OWL, did much better at 75 cents. But their new efficient agent, built on these principles, it came in at just 55 cents. That's a huge improvement. Let's put a hard number on that improvement. By being smart and tuning these different parts, they slashed the cost of pass by 28.4%. And here's the real kicker. They did that while keeping 96.7% of the performance of a much more expensive leading agent. They lost almost no accuracy, but saved a ton of money. So what does this all mean for the bigger picture? Well, this research really points to a future for AI that's hopefully defined by being smarter, not just bigger and more brute force powerful. The researchers use this perfect analogy, and I love it. Building a great AI agent is like tuning a race car. You can't just drop in the biggest, most gas-guzzling engine you can find and expect to win the race. It's about finding that perfect, delicate balance between power, weight, and fuel efficiency. That's what wins championships. And that leaves us with this final critical question to think about. As AI keeps advancing at this incredible pace, where will the true lasting innovation come from? Will it be a brute force race for more raw power at any cost? Or will it come from the kind of clever, elegant efficiency that actually makes these amazing tools accessible and usable for everyone? This research makes a pretty strong case that the future belongs to the efficient. That's all for this explainer.